go up, down, splat, right? Okay. Now, that's great and all, but when I'm playing catch with my kids in the yard, we're not just throwing the ball straight up and then I'm going to jump on top of my kids and catch it. And I'm going to throw it up and they're going to jump on top of me and catch it, right? Okay? We're throwing that ball, as I drop it, we're throwing that ball out, okay? We're throwing it away, okay, from us. So, my question to you is, what's all at play? What factors must we factor in when I throw a ball away from me? The direction? Like, what do you mean direction? Like the angle at what you're throwing? The angle that I'm throwing the ball at. My release angle is what that's called. Okay? So that's something, right? Gravity, we got to bring gravity into it because as soon as that ball leaves our hand, gravity's taking hold of it. Okay? What else? How fast I throw it, right? Okay? Right? So we're going to be able to, so those three things, right? We're not going to worry about wind right now. Okay? We're not going to worry about how heavy our object is. We're not going to worry about the my earlier class said, well, the altitude, you know, like if you're in Denver throwing a ball, yeah, it's going to go farther because the air's thinner than if I was throwing it at the bottom or on the dead sea floor, which, you know, is below sea level. Okay? So, you know, we're not going to worry about any of that stuff. We're going to worry about gravity, the angle we throw it at, and how fast we throw it at. Anything else? One more that we got to worry about. Anybody think of it? Here, as opposed to what? My release height. Yep, my initial height. The initial height that I release it at is going to have an effect on it. So those four things. Okay? All right. So to model this situation,
but can the receivers get far enough down the field? Rodgers in trouble. It's going to get there. They turned 32 yesterday. Does he have a vintage moment in it? In the end zone, it is caught for the win.
That's what we're going to do. We're going to win. And then we're going to run down the field with our helmet off. Because we don't like Detroit Rock City. All right? So that's what we're going to do today. Is we're going to model that scenario. Okay? So, in order to do that, we need to bring in all of those factors that we just talked about. So, here is how we bring that in. We make it be a parametric equation where my x equation is equal to v sub 0. What's v sub 0? That's my initial velocity. Times the cosine of theta sub 0. What's theta sub 0? Theta sub 0. What do you think that's going to be?
The initial throwing angle?
My release angle. Yep, that's going to be that throwing angle. Or, as this picture says, my launch angle. Times t. Okay. So that's going to be my initial outward vector. Okay. Then my y component, that's going to be my height. Remember, x is my horizontal, y is my vertical in the parametric, is going to be negative 16t squared. Negative 16t squared comes from Gravity constant, yep, we talked about that yesterday, plus v sub 0, so that's my initial velocity again, times the sine of theta sub 0, that's my launch angle again, times t, plus h sub 0. What is h sub 0? Initial height, yep. Okay? So, Aaron Rodgers throwing a football, right? Okay, that's one. That would be a model of this one. What else that's starting up right now might be a model for these type of problems? Softball and baseball, right? Okay, hitting a baseball or hitting a softball when you're standing in the batter's box and you make contact with that ball right here and then it goes flying, will you or will you not hit a home run? Warning track power off the wall, hit a home run, all that stuff, right? Great problems can come out of that swinging a softball bat or swinging a baseball bat. Okay? So, let's go with Ryan Braun. Probably the most famous of all the Brewers right now, so we can still use them. This problem has evolved. The last time I taught pre-calculus, it was Prince Fielder. Okay? Now it's Ryan Braun. Okay? Which is fine. Okay? So Ryan Braun hits a baseball which is 3 feet above the ground with an initial velocity of 150 feet per second at an initial angle of 18 degrees. Will the ball clear a wall 20 feet high, 400 feet away? Follow-up question, what is the maximum height of the ball? Okay? All right? So, let's come up with our ball's parametric equation. Okay? So, remember from the last slide, x was equal to v sub 0 times the cosine of theta sub 0 times t, and y was equal to negative 16t squared plus v, oops, that should be a v. Let's make that nice and pretty. V sub 0 sine of theta sub 0 times t plus h sub 0. Okay. So, for my baseball, what is my x equation line? Keep it along there. What's my x equation line there? V sub 0. 150? Agree? 150. Cosine. Launch angle. Actually, here, let's do this. Let me tap the brakes. Let me go color code like yesterday. X equals 150 times the cosine of, what's my launch angle? 18 degrees. That's going to all be in a set of parentheses, and we're going to multiply that by t. Okay? Now, the degree symbol is important because if we're using one of those on-the-wall calculators, those are in radians. Okay? So that degree symbol will override the radians. Okay? So then I got y equals negative 16 t squared plus 150, right? Times the sine of 18 degrees times t plus 3. 3 is where I hit the ball. Yep. Okay. What's the only thing that we have left to figure out for the ball's path? What our t-values are, right? Okay. So let's use some logic here now. We're going to start at 0, right? Because that's the initial, that's when Ryan Braun hits the ball, right? So we're starting at 0, okay? How far or how many seconds is it going to take to get 400 feet? 3-ish? Okay, all right, let's try 3. I'm okay with trying 3. Because if you think about it, it initially left at 150 feet per second, right? Which means in that first second, it's going to travel about 150 feet. In that second, it's going to travel, it slows down a little bit, right? So maybe it travels 140 feet. So now we're up to 290 feet, right? Then maybe it only travels, 120 feet the third second. We're still over 400, right? Okay? So let's graph that. Okay? Let's graph that on our parametric graph. So I need to change my entry into parametric. And then we said, open parentheses, 150 times the cosine of 18 degrees times t and negative 16 t squared plus 150 times the sine of 18 degrees times t plus 3. And we said 3 seconds. Now, am I going to have to change my window? Yeah, okay, because I'm only looking out 10 feet, right? So let's go and change my window. Let's think here now. X's. Let's leave it at negative 10 because I like to see that vertical axis. Okay? How far out do I know I at least have to go? Where's the wall going to be built? 400 feet. So let's go out to 450. I like to know what my scale is. Let's go by tens. Okay? How high is that ball going to get? Rough estimate, let's say. 80 feet maybe? Try it and see. Okay? I'm going to go negative 10 here, and then I'm going to go 80 there, and then I'm going to go 10 there again. Okay? T value, is 3 seconds enough time? Looking at it, is 3 seconds enough time? Oops, now I gotta Control Z, get back here now. Is 3 seconds enough time? Did my ball hit the ground? So is 3 seconds enough time? No. So I gotta adjust my t value to make it hit the ground. Okay? So instead of 3, we should probably go what? 4? Am I okay with it going past the ground? Yep, I'm okay with that. I just needed it for sure to hit the ground.
What are the window settings again?
I went -10 to 450 on my X's and -10 to 80 on my Y's. Okay? So we're there, right? Okay? Ball has now at least hit the ground. We think. We don't know. Could be a home run, could be short. Let's figure that part out next. Okay? So now we have to come up with the wall. Okay? What is the X part of my wall?
X equals 400.
400, because I want my wall to be 400 feet away. Okay? So that sets the horizontal distance of my wall, 400 feet out. Okay? The Y component. I need a function now to build my wall. Okay? So give me a function of t. What, at least 20t? Yeah, 20t works. Okay, so if I choose 20t there, right, what are my t values going to have to be to make it go from 0 feet, because I don't have a wall, right, and stop at 20 feet? What values of t would I have to put in there?
0 and 1.
0 to 1. Yep. What if I didn't want 20 feet? Or 20t, I should say. What if I said t is my function for y? Then what are my t values going to be? To get me a 0, starting at 0 and ending at 20. 0 to 20. What if my function was 10t? 0 to 2. What if my function was t plus 2? No. I need to be at 0, -2 to 18. Yep. Okay. So that function part doesn't matter what it is. As long as you have at the first value here, at this value here, your y equals 0, and at this value here, your y equals 20. And it can be any function. Okay? Good with that? Okay? So like right here. So here's my wall that I'm going to build, right? I need it to be at 0 and I need it to be at 20. If I go with 10t, if I plug in 0, I get 0. If I plug in 2, I get 20. If I go with 20t, 0 and 1. If I go with t plus 2, -2 gets me 0, 18 gets me 20. Okay? Now, let's build our wall. Okay? So I'm going to make a new parametric function. My x value is going to be 400. My y value, we chose 20t. And my values are going to go from 0 to 1. And there's my 20-foot wall. So is it a home run? No. Does it hit the wall? Yeah. Okay. So he's got a chance at maybe a double or a triple, depending on how the outfield's playing. Okay? With me? Okay. So give me a second here. So my first question was, no. My second question was, I want to know the maximum height so somewhere in there, I want to find the maximum height of the ball. Okay? Find me the maximum height. Give me some strategies that you use to try and find the maximum height of that one. Yes, ma'am.
Well, first I tried tracing it because like it tells you the maximum to the top, and it doesn't work.
And it doesn't work on this one, right? So you tried the trace first, right? And then so you went through, I'm going to go over by my computer here because it's easier. And you went through and normally it would tell you maximum height if it was a function. Yeah, but it doesn't, okay? So can I go with 36.5 since that's what those two are? Can I go with that? No, because it's probably going to be something, because that's not accurate, okay? So that didn't work. Then what did you try next?
I tried like going to menu and then analyze graph and then I get maximum.
And maximum. But then it gives you this graph question mark, right? And it won't let you select the graph. Oh, it's frustrating, isn't it? Okay? So that doesn't work. Ay, caramba. So now what?
What I did was that I set on the equations I set the y to 0, then threw out the first number to get the time that it takes to reach the bound afterwards, and then just halved that.
Okay. Oh, okay. So you found where it hit the ground over here and halved it. The only problem with that is at 0, we're not at 0, so I can't go by half. But you're close. Okay? So I can't use the calculator. Rats. Right? Gotta do math. Okay? What shape is this ball's trajectory? It's a parabola, right? Upside down one, right? So the ball takes off and then it lands again, right? As opposed to taking off and keep going up, right? So where on an upside down parabola is the highest point? It's at the vertex, okay? So how do I find the vertex of a parabola? Easy. How do I find the vertex of a parabola? So I'm using that y parabola, right? How do I find the vertex of a parabola? No. Somebody had said it.
Average the two x-intercepts together and then...
But I don't have that other x-intercept. You know what I mean? There's a way that I can go right from this formula to my vertex. Oops, that should be an A. That didn't come out very good. Remember this? Opposite of B over 2A. So what's my B value here? What's my B value in this equation? 150 times the sine of 18 degrees. And that needs to be negative, right? What's my A value here? negative 16. So this is 2 times negative 16. Right? So let's figure that out. So negative of 150 times the sine of 18 degrees divided by, call it negative 32, right? 2 times negative 16 is negative 32. That's going to give me that. So what is that? The x, so the x value of the vertex, okay? But really, what is it? In this equation, what is it? It's our time. It's the time that it takes to get to the maximum height, right? Okay? So that's going to give me my t value, right? So I'm going to store that as my t value. And then I'm going to put that into my negative 16 t squared plus 150 times the sine of 18 degrees times t plus 3 function. And that's going to give me a height of 36.57 feet. So the ball gets up to a maximum height of 36.57 feet. Okay? That's all she wrote for today.